All right. So, what is the domain of the first one? Oh, great.
Ten, 20, 30, 60, 100.
So smart. You all got that right, didn't you? Yes. Gabriel, what's the range?
5, 5, 5.
No, 500.
Right. Again, if you wrote it more than once, that's okay, but you don't have to. All right. Is number 2 a function or not? Timothy? Yes. Very good. Every one of you have one and only one number of pets. Joe, what are you looking at?
Hey,
We're trying to talk to Debbie.
Oh, now you're
Put those phones away. All right? Again, it's just talking about each person here and how many pets you have. Okay? It could be 0, could be 1, 2, or 3. None of you have more than one number of pets, right? You got so many pets. You might have 2, you might have 5, you might have 0. All right? So remember, for every x, so each person in here is the x, there's one and only one y. There's only one and only one number of pets that you have. Okay? So that's a function. Ava.
It's like, it just doesn't stick with me whenever you say that last part.
Well,
Saying that there can't be more than one y for each thing.
correct.
But like, how would that be written if there is more than one y?
Well, you would just see it, you know, you would see the set of ordered pairs, and you would see that there's, like on homework, there was one that, was it 7 every time? For x? What number was that, Liz?
Yeah, it is.
24. So you had 7 and then a bunch of numbers, right? A 7, 1, 7, 2. So that's an example of an x that had more than one y, so that's not a function. It's still a relation. Set of ordered pairs is just not a function. Okay? Okay? So what a lot of people think is that we all should have the same number of pets. That's not what we're saying here. Each person in here has only one number of pets, and that number could be 0. Okay? So like for me, I would have 1 next to mine, because I have one dog. All right? For Isabella, do you have anything beside that dog? So hers would be 1. All right? You got any pets? The dog too? So all of us would have the same number, but each of us only have one number of pets. Does that make sense? Okay? Now we think about a city. Does every city have only one zip code? No. Because some cities are really big, so they have so much area that they have a couple zip codes that if you would have to go to even Canton or Akron, I think have more than one. So this would not be a function. It's still a set of ordered pairs, right? Still a relation. It's not a function. Okay. Is number 4 a function? No. Doesn't pass the vertical line test, right? Okay. Number 5 is looking at number 4 and state the domain. Let's put it domain and range in interval notation. So what's the domain in interval notation and what's the range? Okay,
domain is -4 to +4.
right, so how do I write that in
Interval notation.
interval?
The bracket thing, the square bracket, then the numbers, then the other square bracket.
Good. We're squaring it because we are including the negative 4 and the 4, right? What if I change this picture just slightly and put a circle at that point and a circle at that point? And then the red comes right out to there and out to there. So the red's not there, there's a circle instead right at those two spots. What's my range in interval notation? Cole? No? Gabe?
Negative, or 3, -2.
What's around it? Well, if I don't have the blue circles, yes. So the blue circles, if I added to it, it would be what? Just a parentheses. The parentheses telling us what? We're not including that number. Remember? Okay, that was on our last quiz, right? It's going to be on the test next week, too. Good. Good for you.
Yeah.
Looks like it's going to be Wednesday. Okay? Looks like quiz or test, chapter 1 test, Wednesday. All right, let's go over answers to last night's homework. Make sure we understand. It was pretty easy, wasn't it?
Hey, I like to.
Okay, so number 2 was domain 0, 1, and 2, and range -2, -1, 0, 1, and 2. Number 4, it is a function. Each person had one and only one score. Number 6, that is not a function. So if it wasn't a function, you were supposed to pick 2 points that a vertical line would pass through, and they use the book 2, 1, and 2, 0. But again, there's multiple answers for that. Number 8 is not a function, and the points they used was 2, 2, and 2, -2. You could do 4, 3, or 4, -3. Those are the possibilities there. Number 10, domain is -3, +2, 3, and 4. Range is -2, 1, 3, and 4. Number 12 was a mapping diagram. The top, they did it horizontally, so the top would have been the x's and the bottom would have been the y's. Therefore, it's not a function because that 3 has 2 different y's. Number 14 is a function. It does pass the vertical line test. 16, the domain and range are the same numbers, -5, 0, and 5. And again, I'm not worried about you guys being able to do a mapping diagram. 18, domain is -2, -1, 1, and 3, and the range is -3, 0, and 3. Number 20, domain is -1, 0, 1, 2, 3. Oops, that's wrong. That was 22. 20, the domain is those letters. They did it in alphabetical orders. They did E, N, S, V. And then the range is what number in the alphabet, when you put them in order, is it? So E is the 5th letter, and N is the 14th, and S is the 19th, and V is the 22nd. So it's 5, 14, 19, and 22. 22, again, I started doing that one. It is a function. And the domain is -1, 0, 1, 2, 3. And the range is -1, 1, and 3. 24, domain is 7. That's the one that Liz told us about. And the range is 1, 2, 3, 4, and 6. And that is not a function. 26, the domain is -3, -1, 0, and 3. The range is -4, -3, -2, -1, 0. Not a function. 28, The domain is all the months, the 12 months we have in a year. And the range would be 28, 30, and 31. Those are the number of days in each month, one of those numbers. Number 30, you could say it's a diamond or a square. No, it's not a function. A vertical line would pass through 0, 20, and 0, negative 20. And the domain in range is the same. It's negative 20, 0, and 20. 32, A to B and B to A are a function either way. So you say both. 34, also both. And 36, just from B to A, you have a function. Each NFL football player has one jersey number, but jersey numbers have more than one NFL football player, right? So, questions? Go.
So can you explain, like, what's the difference between 22 and 24? How 22 is like a function and the 7, like, isn't for 24?
Okay. So 22, if you look at, they gave you a graph, right? And if you draw a vertical line through each point, you only just hit that one point, right?
Yeah.
So it passed the vertical line test.
Alright.
That means every X
And then
had one Y.
the 24, like, if you do the line, all those points would be through, is that why it's not a function?
Right, those all would line up on the same vertical line, right?
Yeah.
Yeah. So that means there's those, that X7 had, whatever, 5 different lines.
Yeah.
Yeah, so that's why it's not. You're welcome. Anything else? Clear as mud? That's good, right? All right, today we're going to talk about function notation. All right, so we're going to give, and basically, they look like equations just now. I've been, thanks. Yeah, Nate reminded me before when I get going. And then we're going to evaluate and graph these functions. Okay? So again, we're getting closer to using this. So get this if at all possible. If this is really a problem getting, because of, it's expensive, I know. If that's really an issue for you, come see me, we'll figure something out. Again, last couple years, we could download them on our laptops, but that link has been canceled or whatever they do, and we have not been able to find them. Okay. Some kids have found this as an app for like $5 for their phone, but when we have tests and quizzes, I'm not going to let you pull that phone out for your calculator. Okay? So, if you can get a handheld one, and again, we just haven't been able to find a download on the laptop. If any of you find one on the laptop, let me know and we can share it with everybody. So, function notation, we're going to talk about dependent variables and independent variables. So, when we talk about this stuff, when you leave, you should understand what we're talking about. So, some sets of ordered pairs, relations, can be described by using an equation. Let's get this side going so some of you don't have to turn your head if you don't want to. When the set of ordered pairs is described by an equation that satisfies the definition of a function, we can say the equation can be written in function notation. So, an easy equation that you guys know is y equals mx plus b, right? You guys remember that one? See that a lot? Well, we could write in function notation f of x equals mx plus b. That's the same thing, all right? F of x means the function f. That's the name of it, whatever this letter is. Most of the time they use f, but they'll use g and h. A lot of different letters, but most of the time you see F, G, or H for a function. Yes? Yeah, I did.
Oh.
We got it going. But thanks for trying to remind me. I need that. All right, so I could also say y equals 5x plus 3 here. Okay, so f of 1 means to do what with the 1? F of 1 means to do what with 1? Just replace the x with the 1. That's all that means. Okay? So if you see this, they'll give you this ahead of time. You know that you're supposed to put a 1 in for the x, which would be what, 8? So you write f of 1 equals 8. So the point would be 1, comma, 8, if we had to graph it. Okay? So again, that's what I was talking about. Y equals fx plus 3 is the same as f of x equals 5x plus 3. So our point is xy or x f of x. These two are the same thing. That's all. Okay? Again, the graph of a function is a picture of the function's ordered pairs. Well, that's what a graph is. It's a picture of all the answers to the equation. All the points that work. That's what a graph is. It's a picture instead of you writing it out. Okay? So far, so good? Making sense? Good. So again, doesn't mean f times x. All right? Means the value of f at x. So f of 1 represents the value of f at x equals 1. So, Derek, what is f of 0? So look what we did here. F of 1 meant put a 1 there. Good? Yeah, the 8. Because what are you going to do with the 0? Yeah, you're going to put it in for the x, right? And 4 times 0 is 0 plus 8 is 8. Audrey, what's f of 1/2? Good. What's 4 times a half? 2. What's 8 plus 2? Very good. Kendra? Very good. That's the negative 8. 8 plus negative 8. We call 8 negative 8 additive inverses, right? Opposite. Hunter, making sense?
Yes, sir.
Right. Mary? Making sense? Okay, Mary. What's f of 0 for this?
Oh. Hold up.
Hunter, you can try to help her out.
Come on, Mary.
What do you think? Okay, so let's go back. Okay, remember, what's this? F of x means, doesn't mean that times or multiplied. It means the value of f at x. So f of 1 represents the value of f at x equals 1. Right? So whatever is here is what the x equals. What you're looking for is what the y equals. Okay? Does that make sense? Is that helping? So, Mary, when x is 0, what's the y? Yes, it would. Very good. Does everybody understand why it's 3? Find, remember, this is the x values, right? Find the 0, and then go find the red line, right? It's at 3. That's the y value, right? I'm looking at that point right there. Okay? Nate?
Oh.
F of 1/2. 0, good. You go find the 1/2, and there's the red lines right on it, so that's 0. It didn't move any. Grace?
Would it be 4?
Is that a 4 there?
Yeah.
It would be 4. Very good. So, I expect you listening, you should be able to evaluate a function when it's written out as an equation, or you get a picture of a graph. You should be able to find the answer to the function also, both ways. Okay? Questions? Simple, right? All right. So, Garrett.
I'm gonna fill in a 0 squared. 0 times 0 is 0. And 0. And then it's kind of equals 0.
Very good.
Let's go.
Hunter,
Yeah.
go ahead.
Should be 1/2 squared, then negative 4 times a half.
What's 1/2 times 1/2?
1.
1 over
4.
4, 1/4, right?
Yeah.
Square the 1, square the 2. What's 4 times 1/2?
2.
2. Or think of half of 4 as 2, right? So what's 1/4 minus 2?
3/4. 1.5.
1/4 minus 2.
1.5.
Close? 1/4
Negative.
minus 2.
1 and 3/4.
Yeah, negative 1 and 3/4.
Hope I don't get the extra one. That was impossible, but yeah,
Robert? That's 4, yeah.
Wait. Let's go.
Right? Is that what's going to happen?
Yeah.
Liz? Oh, guess there isn't another one. You're lucky. In the notation, f of x, f is the name of the function, the output, f of x. So the output of a function is called the dependent variable because it depends on the input value of the function. So what letter are we always inputting for? X. So the x is the independent variable, and the f of x or the y is the dependent variable. Okay? Because the y or the f of x depends on what the x equals, right? That's what that's saying. When you graph a function, the horizontal one is the independent one, that's the x-axis, and the vertical one is the dependent one, which is the y. Okay? So, there's a little graph of a function. This is the d function. d of t equals 65 times t. It's like distance equals rate times time formula. Right? So, when t is 0, we're going 0 miles per hour. But when t is 1, we're up at 65 miles per hour. When t is 2, we're up at 130 miles per hour. Or not miles per hour, but 130 miles travel, distance travel. Okay? So this is basically number of hours. This is our number of miles. All right, so when we graph that function, what do? Ms. Studebaker? Yeah, just go over 0. No, I guess we don't go anywhere 0, right? Just go up 4, right? And then what? Go over 1, up 5, and over 2, and up. So we just plot the points, right? But those are, since my x's are positive, my y's are positive in that first quadrant. Okay? Do not connect the points because the values between the given points have not been defined. Okay? So if you're just given a set of ordered pairs, you just plot the points. Okay? Does that pass the vertical line test?
Oh, yeah.
Yeah, so that's still a function. That's called a discrete function when you don't connect them. So we didn't connect them. So if you ever hear the word discrete function, we're just not connected the dots. All right, here's a function, an equation. You know, you're used to y equals 3x minus 1 instead of f of x equals same thing. So what was the thing you guys were taught the very first time you were supposed to graph something?
You go on X version.
Yeah, you pick out x numbers, right? What numbers did they tell you to pick? Did you do this? You guys ever see that before?
Oh, I did.
Back freshman year when you first were taught, or maybe 8th grade depending, graph and they give you an XY table, right? And they probably told you to use these 5 numbers, right? That's how I was taught when I was a freshman. Way back when. What years do you think that would have been?
95.
That one?
98.
55? I wasn't even born yet. Come on, Sully. Give me a break.
79.
79 is when I graduated. So 76. So that's what this is. It's just, you guys are just used to this, used to seeing this be x, and here's the y, and this part is just the work they're doing. But you knew what to do. You plugged in the number into the equation, or in this case, the function, to figure out the y or the f of x, right? But watch what you can do with this. This button right here says y equals. And then I can just plug it in. 3, right next to alpha there is the x button. minus 1, hit enter. This button says graph, hit graph, and it'll graph it for you.
What did you do?
I just graphed it on my calculator.
Dang.
Are these two graphs the same? Yeah, they're the same, aren't they? So again, we will learn how to use this graphing calculator to graph stuff for ourselves. We could also get the table of values. If you hit second graph, above graph it says table. There's our XY table. Okay? X is right next to this alpha button here. You see an X, a T.
Ah, see.
Okay? Okay? What's my points for this one? Who can tell me the points, Drake?
It would be 3,
What?
2,
3, 2. Good.
5, 6,
Good.
7, 10,
Yep.
and 9, 10.
Good. That is correct. All right. So that's what it would look like. Just those points. So that's a discrete function. We didn't connect the dots. Right? This one we would just put our XY table in, right? And we can pick any numbers we want for X, right? We just usually pick the -2s, -1s, 0s, 1s, and 2s, because those are easy numbers to work with, right? But you can pick any number you want. Okay, so they just use -1, 0, and 1, okay? But we connect those. When it's in an equation form or function form, we connect it, make our line. All right. Any questions? Get it? Got it? Good? So Monday, we'll go over this. I'll give you the practice test. Tuesday, we'll go over the practice test. And then Wednesday next week will be your test on chapter 1.
Ow.